All right, so the purpose of this video is to explain and look at, this is classroom, mine's on physics, RL4, specifically called Snell's Law. I will make an effort to go through the majority of these question groups. And to start with on this, we want to look at this first one. It's asking for the angle of incidence. Remember, these show arrows with a pointy side. So that tells you the direction that it's going. So the angle of incidence is always the first one. It's the angle coming in. And angle of incidence is always off of the normal line. Remember that. That's another really important thing. It's off of the normal line. And so this angle would be B right here. The angle of incidence would be B. This would be another type, basically the same question, only it's asking about refraction. That's of course the second one, so in this case it would be E. It would also be something like F, 180 minus F minus D or something like that, but those aren't options over here, so in this case it would just be E. All right, this one right here, to do it, you just kind of have to do a little logic, and you have to think about some basics of just triangles. So all of these triangles could be made thinking about this. This would all be a triangle. And a right triangle. And so if this angle right here, these are 90 degrees. Well then, and one of them is approximately 30, so you have a 30, that would be, this one would be 30, because your other option is 60. And clearly you would want the smaller angle there, because this side is shorter on the smaller angle. This side is longer on the bigger angle. And so that's how you kind of know which one's 30 and which one's 60. And to know which one is incidence versus 30, the first thing I would do is I would always draw a picture of this, and I would make sure and draw that normal line on these. So you remember there's a normal line. Okay, that's a horrible drawing of that normal line. Something like that. And remember, this is the first side here, because of the direction of these arrows. This is the first side here because of the direction of those arrows. Since it's looking for an incident ray, you're looking for the first side of 30. Here you would have A, that'd be a 30 degree. This is a angle of refraction of 30, but not incidence. The incident down here would be 60, and right here it would also be 30. So this one would be A and C. Oops. Similar question like we just did. This one is where it started to get, I would say, a little tricky. And so ultimately what we're looking for here is use the diagram and Snell's law to determine the value of index of refraction of the material. So the first thing I'm going to do is grab Snell's law. So our equation of Snell's law rearranged does look like this. It was in your notes. It also is n1 sine of theta 1 equals n2 sine of theta 2. I think it works best. I think when we're doing this, it works best just to use n1 over n2 in this format, and I kind of have it written here. And when you're looking at this, to start with, there's no real refraction happening here. The angle's 90, so you kind of have to ignore what's going on here. And you really need to zero in on this situation right here. And you also want to make sure and realize this is your surface here, right? And so your normal line is at a 90-degree angle perpendicular to that. So remember, this is your normal line. And your angle of incidence and your angle of refraction are in reference to that. So you're really looking for this angle here and this angle here. And I think it's always useful. You always want to label one of these as 1 and one of these as 2. Just a little tip. This is out here is air. Just everything out here is air. And that air can actually round to an N value. The N value of air rounds off to 1. If you go far enough out, it's not 1, but it's about 1. And just a little tip, if you label air as 2 to be in the second value, I like to write on my paper, just write it down 2 and then 1. Then when you put air in over here for your index value, it kind of makes it more simple. You don't have to do that, but you've got to label each of them a number, and then you're ready to go. You simply have 3 of the 4. So what you would do is you would take the N value of air, that's 1. Your ultimate question is what is the index of refraction of this yellow material, and that's going to be N sub 1. And then you're going to make that you have both of these, if not directly, indirectly. And this is where, when you got 1 and 2 here, what is 2 and 1? Well, you look at this. Sine of theta 2. Well, what is this angle? Since this is 90, since this is 165, this would be sine of 75. And then the other one would be sine of 45. Again, might have to do a little bit of arithmetic. That would be 45. Now, this is going to give you a number here. So in this situation, we would find N1, if you do the math there, to be 1.366. If you would do the logic test, does this even work? If this is a wave front going along, and as this side over here speeds up, would it in fact bend away from the normal? And it would. So the logic test does pass. Oops. The only other one here that I want to make sure and touch on, the main thing is you just got to remember to draw that normal line and then label each side. Is when we get to these, there's a couple of these that have this, and you should know that this is a way to measure angles. Set this dot right there on the end of the point. And when you set it on the end of the point just right, you'll notice that it's always going to be an even increment of this. Well, what on earth are these? Well, think about it. This right here is 90 degrees. 1, 2, 3, 4, 5, 6. 90 divided by 6, these are 15s. So we know that these would be 15, so we know this is going to be 45 and 45. But if you're trying to find out, it wants to know the angle of refraction in degrees for this light ray. The way you would do that would be extremely similar to the prior one, only this time you don't have the angle. First thing I would do is I would make sure, and I would want to draw the normal line. Remember, draw this normal line. And I would label a side. I would label this side number 2. Remember, that's just a trick that makes the math a little easier. And I would label water number 1. Then I would want to come up with these angles here. What is my angle of incidence? Well, in this case, I know it to be 45 degrees, as I kind of already explained. This angle here, 15, 15, 15, that would be 45. We're going to use the same equation from before. Just for time's sake, it would be this equation. I'm going to go ahead and put those numbers in. So if you work this through, of course, you end up with 1.33 equals the sine of 45, which is something like 0.707, divided by sine of our angle, sine of theta 1. You gotta be a little bit careful here because you end up, and a lot of people mess up, this is just basic algebra, but you need to either do this as a two-stepper, multiply times sine of theta by both sides and then divide, but ultimately you end up doing 0.707 divided by 1.33. And you're going to end up with a number you're going to end up with a number 0.5317 is equal to sine of theta. This is absolutely not the answer. You got to do the inverse sine of that, and then what you end up finding is that if you get everybody's calculator is different, but you got to do the inverse sine. 32.118 degrees in this case would be equal to theta. You got to do one more step. That is theta 1. And so what that says is this angle right here, this is going to be coming this way, is in fact that angle right there, 32.118. And that does pass the logic test because if you think about, if you can imagine this wavefront coming in here, if it's coming along and this side slows down first, this side would swing around for more thinking and it would refract towards the normal. So that would in fact pass the logic test as well. If we jump on to the only other type of question, it is very similar to what you've seen here, only this one is just going to be asking for the index of refraction, or it might be, I don't actually see a difference here in these. Oh, you don't have a value of 1 is the only difference I can see maybe. Thank you. I hope this helps and good luck.